right, so we are going to work on problem number 2 from the back of the chapter. This is on page 470. And it just says, calculate the sum of products for the following scores. Note both means are decimal values, so the computational formula works well. Well, guess what? You know that we're not dealing with definitional and computational formulas. We're just doing the ones our calculators want to run. So don't worry about any of that stuff in the chapter, right? We're just going to do it the best way we can. So the first thing we're going to do for this problem is basically we're just going to run our steps, and it doesn't tell us we're going to run it at a 0.05. So we're just going to use that data to do the whole thing. So let's start with, let me get the data written in here. Now, before we get rolling right into our prep work in step 1 through 4, let's do a scattergram. Let's build a scatter plot graph together. You've seen the slides, but it'll just be our first time doing one together as a class in many chapters. So, all we want to do is we are going to get some graph space set up. All right, so we have our axes up. I probably could have pushed all those numbers out a little bit further, but that's okay. Good enough for what we're working on here. So remember all our rules from graphs back in chapter 2. We need our axes of roughly the correct proportions. We need them numbered. We need them labeled. This is a generic problem. We don't know what variable x or y is, but so we're going to label it variable x and variable y. So remember, we always want that. Axes of good proportions, numbered, labeled. Next, we're just going to start logging in our data. So for the first pair of scores, remember these are a pair now. This one person who scored a 0 on variable x, and that same person scored a 4 on variable y. So over to 0, up to 4, and put a dot there. It happens to be right on the axis. A 1 and a 1, over to 1, up to 1. A 0 and a 5, 0 and up to a 5. A 4 and a 1, over to 4, up to 1. A 2 and a 1, over to 2, up to 1. And a 1 and a 3, over to 1 and up to 3. So we have all of our dots. Next thing we would want to do, again, because it's a visual tool, is give us an envelope around this thing. Let's get a sense of sort of how the dots are arranged. And if we really needed to estimate a trend line, we could do that. That would probably go about like this. So its form is going to be linear. Now I know you're looking at that and probably thinking, that's kind of curvy, Paul. It's a little bit of a curve like this. Well, here's something to know right now. The Pearson R can only process for linear forms. So all these problems, if you're doing Pearson R's, they're all linear forms. So it's a gimme question, if you will. The form for any data we're actually running this analysis for is absolutely linear. You should be able to recognize other forms when you see them. So we've got a linear form. What direction do we have? It's going down to the right. So we've got a negative direction. So what is this telling us? This is telling us that this data is got low precision. If this is our trend line, we've got dots that are quite a bit away from it here. So we're expecting a result that's probably not all that far from 0. I would say probably in the 20s, maybe 30s. And we're going to expect a negative value for it. Again, that's the ultimate purpose of building these first, is to give us a reality check for our answers. So we've got our scattergram completed to give us a head start. Now, what we really need to be doing to get the 4 steps done from here is we need to be getting all those prep values that we needed. So we need to know x squareds, we need to know y squareds, and we need to know the products of x and y. So this is how I generally do it. I kind of build it myself a little table here, if you will. Go away, fly. All right, so the first thing we want to do is just add up this column. This is our little summation row, if you will. So what's the summation of the values for variable x? 0 plus 1 plus 0 plus 4 plus 2 plus 1. So it's 6, 7, 8, right? So this value is 8. The summation of x is 8. The summation of y, 4 plus 1 plus 5 plus 1 plus 1 plus 3. This adds up to 15. Again, as always, I recommend that if you want, hit the pause button real quick, do these calculations yourself, make sure you're able to get them. Next up, square our x's. Well, 0 squared is 0, 1 squared is 1, 0 squared is 0, 4 squared is 16, 2 squared is 4, 1 squared is 1. So first we square the values, jumping over that middle column, and then sum them up. 0 plus 1 plus 0 plus 16 plus 4 plus 1, 22. Next thing, same for our y's. So 4 squared is 16, 1 squared is 1, 5 squared is 25, 1 squared is 1, 1 squared is 1, 3 squared is 9. So 16 plus 1 plus 25 plus 1 plus 1 plus 9 gives us 53. And then lastly, our sums of products. So we'll go back over here, x times y. 0 times 4 is 0. 1 times 1 is 1. 0 times 5 is 0. 4 times 1 is 4. 2 times 1 is 2. 3 times 1 is 3. So 0 plus 1 plus 0 plus 4 plus 2 plus 3 is what, 10? Yes, 10. Every one of these little summation values at the bottom of these 5 columns is something we're going to be plugging into a formula in step 3. So there is our preparation stage, if you will, getting ready to run our Pearson R. So in the next clip, we'll pick up with step 2.